Hi folks, we're going to take a look at number 19 from page 335. So they give us this scenario here where we've got this rectangle for which we're trying to find the area. And they give us some dimensions of a triangle that's inscribed inside that rectangle. And they want us to determine the area of the whole rectangle. All right, so there's a way that we can solve this more algebraically. Unfortunately, we don't quite have the tools to do that, but by the end of this course, we will have all the tools that would allow us to solve in a more algebraic fashion. But for now, let's see if we can use our knowledge of geometry. All right, now the first thing I notice here is the dimensions of this triangle. And I see 6, 8, 10, and 6, 8, 10 reminds me a lot of 3, 4, 5. Okay, all the dimensions are just twice 3, 4, 5, and what hopefully you remember is that the 3, 4, 5 triangle is a right angle triangle. Okay, and since they're all twice as big, you know that this triangle is just a similar triangle to the 3, 4, 5 triangle, but we should show that. And in fact, if you show 6 squared plus 8 squared, what do we get? 36 plus 64, which is equal to 100. And then, of course, 10 squared is also equal to 100. Okay, so what we've confirmed now is that this is a right angle triangle. Now, the question is why is that of any importance to us? Well, notice that we're trying to determine the area of this whole rectangle. But if I know that this triangle is a right angle triangle, okay, if I sort of redraw it on the side, okay, and this is a right angle triangle, that means that 6 could represent the base of this triangle, and 8 could represent the height of the triangle, and I could find its area. So the area of my triangle is going to be equal to just 6 times 8 divided by 2, which is 48 divided by 2 is 24. All right, so now the question is can the area of this triangle help me determine the area of the whole rectangle? All right, now I want you to think about the relationship between rectangles, or in fact quadrilaterals, and triangles. You can think of a rectangle as being divided into two triangles, and you realize, hey, the area of the lower triangle is the same as the area of the upper triangle because they have the same base and height. Okay, and so the area of the triangle is half the area of the whole rectangle. Okay, and you can even do this with parallelogram and so on. Okay, so I'm actually going to show that the area of this triangle is half the area of this rectangle. Now that is a property here, but it's not something we've established, and I don't think it's something you would have established back in grade 8 or 9. So we're going to have to justify that. Okay, but here this is not just split up into two triangles here. But this is where I'm going to draw a very clever line. Okay, I'm going to draw a little line here going straight down. Now what's important is that this line is parallel to that line, and of course also parallel to the other height of the rectangle. And look what I've produced. I've produced two rectangles, okay, that look exactly like this. So I realize that this portion of that right angle triangle is half the area of this rectangle. This other portion of our right angle triangle is half the area of the full rectangle there. Okay, so what can we say is we can say that the area of the triangle is equal to 1/2 the area of the rectangle. So in other words, the area of the rectangle is just going to be equal to 2 times the area of the triangle, which was 24. And so the area is 48, and I believe this is in centimeters. Yeah, so we can say centimeters squared. Okay. So let's recap. There was two parts to this problem. First of all, we had to realize that the triangle given was a right angle triangle, and that allowed us to find its area. And then we had to justify the fact that this triangle here was actually half of the whole rectangle. And I did that by splitting up the triangle into two smaller triangles. So I showed that this portion was half of that part of the rectangle, and this portion here was half of the left portion of that rectangle. Okay, so there you have it, 48 centimeters squared. That's it for this one.